Hi, welcome to the shop. Now you're going to listen to my dad talk about nerdy stuff that may or may not matter in the future. Have fun and sit tight. You'll be bored in about 10 seconds.
Oh, that's good coffee. Well, anyway, I drink way too much coffee, but welcome back to episode 2. In this episode, I'm going to show you how I hacked my dust collector to add multiple switches so I'm able to control it from various remote locations in my huge shop that really isn't very big, but it's going to save me some steps and some walking around. So let's go ahead and get started. So the very first thing you need to do whenever you work on anything electrical, and it's best just to err on the side of caution no matter what voltage it is we're just going to disconnect it. So now that this dust collector, and I know I'm tracing the cord back to the dust collector, it is de-energized, unplugged. There's no way that it can work. So now that we have our dust collector disconnected from the power, we're going to go ahead and remove this screw, and that will allow us access to this connection box, junction box. This particular junction box pulls up from the bottom. I've had this apart a lot of times. So this dust collector comes with an RF remote, and it probably works great. I've seen a lot of reviews for complaints about this particular model's RF remote, and I've found that sometimes it works, sometimes it doesn't, and I end up just walking all the way over here to turn my dust collector on. So again, here's the switch, push, 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 and here's what the switch looks like on the inside. So with the connectors removed, I'm going to go ahead and place the multimeter. Remember to always double check that it's beeping before you begin. Put the multimeter, and I'm going to connect the probes of the multimeter, and it doesn't matter what side you put it on. I'll put the multimeter on each part of the switch. Okay, you notice how there's no continuity, there's no beeping. That beeping, remember, is a sign that there's a circuit going through there. So once I push this button, we have continuity. Let go of the button, we don't have continuity. Push it, we do. Let go, we don't. So that tells me that this switch in the shelf state, i.e. there's nothing acting on it, is a normally open switch, which means that there's no current, no circuit going through it. So when I put the probes on the terminals, nothing. Now when I act on the switch or push it in, it creates a circuit, or it's closed. So that's closed and that's open. Again, when you push it in, it's closed. When you release it, it's open. So that is a normally open momentary switch. Momentary means that you have to push it, and it does. It's either going to close or it's open when you push it. And then as soon as you release it, it's going to let go. It's a moment in time. Usually when I do a project, I usually come up with some form of a sketch or a CAD file or a model, depending on how complex it is. So to keep things kind of straightforward, I went and drew this schematic up, and it's 4 momentary switches. I only have 3, so if you just took this one out, and here'd be your 3. Here's my dust collector. These are all wired in parallel, so you can turn it on with one, you can turn it off with the other. You can turn it on with one, you can turn it off with the other. You can turn it on or off with each switch independently. And this is the switch I used. It is a momentary on push button switch. I purchased at Menards for about $4, and they seem to work well. This is a momentary on switch. It's a GSW22. It says momentary on, push button switch. Okay, again, they're like $4, $4.50. Okay, so all I did was I used a Unibit to drill a hole through this faceplate, because this is going in a junction box, and this should have the same response as that switch over there. And I know I'm going in way too much detail, but okay, so I have the probes hooked up to the back side, and when I push this button, and that should turn my dust collector on and off. So this is the dust collector, and you can see I added 2 wires sticking out. They're low voltage. And then I just added these push-on spade connectors. And then the whole thing is wired up with solid core bell wire or thermostat wire. And that goes all the way around the room. You can pick it up at Menards. It's fairly inexpensive. So here's the switch. And again, the power is off. It's completely disconnected. And we'll pull this up and I'll show you the inside. So here's the top switch where the 2 blades are connected. And all I did, now keep in mind that if you do this at your own risk. Because, you know, be prepared to possibly replace your whole dust collector or all the internals. But if all these are made the same way, this should work, although I don't recommend doing it. But so what I did was I pigtailed out, and these 2 red wires go into this PC board here right next to the IC, and then I just stripped them and soldered them together and heat shrunk taped them. I added 2 blade connectors, and then I put pigtails in so they come out of the junction box, and that's what goes around the rest of the room. I chose to not bypass that switch because then I'll have another way to turn my dust collector on and off. Then we're going to go ahead and tuck all this stuff back in. Put her back in, making sure no wires are in the way. Then I'll show you what I did on the other end. So I added a switch here. So when I'm taking a cut, why didn't I move that chair before I started? So when I'm taking a cut, I can easily just bam, hit my dust collector switch. My dust collector will turn on. I can go ahead and make my cut and turn it off after I'm done. Then, and I don't like this placement, but I really didn't have any other option as to where to put it, because I didn't really want to put it on the actual tabletop. So I put it back here in between these 2 switches. So when I run the CNC, all I got to do is hit this button and the dust collector will turn on, turn off. And then between these 2 pieces of equipment, which is my surface planer on the right and my joiner on the left, I added another outlet box, and this is where I got it taken apart so you can see. It's essentially just a momentary switch, 2 screws. Polarity really doesn't matter in this case because everything's in parallel and it's low voltage. So then that's how she looks. So if I go ahead and turn this on here, I can turn it on and off right here locally at the dust collector. And when I'm over here making a cut with my miter box, I can just hit this button right there and it turns my dust collector on and off. so I can turn my dust collector on and off here. And as promised in the introduction video, I added a button here. So I can turn it on there. The nice thing about this is if I forget and I walk away and I'm like, hey, my dust collector's on, I can come over to this switch and just hit the button and it'll turn it off. Hey, thanks for watching episode 2. In this episode, to recap, I hacked into my dust collector. I installed 3 external switches. They're momentary switches, normally open. You push them, it closes the circuit. You let go, it opens the circuit back up. That is how my dust collector works. And it was successful. Again, please be careful. I don't recommend that just anybody goes ahead and does this hack. It's you have to have understanding of circuits and high voltage. I mean, it's not really high voltage, it's 110, but it can hurt you, could potentially kill you, could burn your house down, and it will definitely void your warranty. So with that, basically keep thinking, keep making projects,